before we do number 8 on the back, when you do any problems in circuits, you have to know the relationship for resistance, current, and voltage. You have to know the difference between series and parallel. Regardless if you're going to do a complex problem or you're going to do a simple problem, you have to know that in series, the resistances add up. You need to know in parallel, it's the reciprocal of, it's 1 over the resistances add up. You need to know that the current in series is the same. Understanding that the current in series is the same is essential when you're working complex problems and you want to know how to simplify them and what to do. In parallel, the current adds up. The voltage in series adds up, and in parallel, it's the same. So, when we're doing problems, this is going to help us to figure quantities out that we don't know. What we're going to do is we're going to use this Ohm's law, V is equal to IR, over and over and over and over again. We can apply it for an entire circuit. We can apply it to an equivalent part of a circuit or just to one particular resistor. All right, so now we're going to look at number 8 on the back of the worksheet. So here's number 8, and I'm going to find every single thing in this problem. So I'm going to find the current through every resistor. I'm going to find the voltage drop through every resistor. But the difference between this problem and some of the ones we've done before is they're not giving me the voltage of the source, they're giving me the voltage in one of the resistors. So the first thing that we're going to do is we're going to draw our diagram. Because after we have our diagram, this diagram and our intermediate schematic diagrams are going to help us to solve the problem. So R1 is 1. R2 is equal to 3. R3 is equal to 10. R4 is equal to 5. And R5 is equal to 0.5. Now, the only other thing they give us in this problem is V3 is 30. Instead of identifying that first, let's do what we've done in every single problem before this. What we're going to do is we're going to simplify this until we get one equivalent resistance. Okay? So, how do I know what order I can combine stuff? I'm going to look at the current coming out of the battery. The current is like water flowing through a pipe. If it's all flowing the same, that means that they're in series. If it splits and divides, it means they're in parallel. So the current coming through this first resistor, it's the same as what's coming out of the battery, because there's only one way for it to go. When it goes to this point, part of it's going to go here and part's going to go here. Now these two are not in parallel because this is actually in parallel with all three of these. So what's flowing through here, I see, if I cover this up, you see that looks just like a series circuit, right? So this is in series. Then it comes back together here, and then the total current's going here. So what I'm going to do is I'm going to simplify this. I'm going to take this, R1 I'm going to leave alone. And I'm going to leave, I forgot to write what this one was, R6 is equal to 6 ohms. I'm going to leave that alone. I'm going to leave R5 alone. And instead of R2, R3, and R4 in series, I am going to R2, R3, and R4 are in series. So what I'm going to do is I'm going to add them together with an equivalent resistor I'm going to call R2, 3, 4. Now to find out what R2, 3, 4 is, what I do is I add resistors in series. So R234 is equal to R2 plus R3 plus R4. So that's equal to 3 ohms plus 10 ohms plus 5 ohms. So R234 is equal to 18 ohms. So now R234 is an 18 ohm resistor. So I have my total current coming out of the battery. It goes through here. At this point, it splits, and then it comes back together here. So this resistor and this resistor are in parallel. And if you're not sure, if I cover it up, doesn't that look like two resistors in parallel? So what I'm going to do is I'm going to redraw it. I have R1 is equal to 1 ohm. I'm going to leave R5 alone. And instead of R6 and R234 in parallel, I'm going to have a resistor I'm going to call R2346. Now to find out what the resistance of that equivalent resistor is, these two are in parallel. So I need to add them in parallel. So 1 over R2346 is equal to 1 over R6 plus 1 over R234. So that's equal to 1/6 plus 1/18. And see how the math here is easy? So I don't even need a calculator. I would find the common denominator. So the common denominator would be 18. So 1 over R2346 is equal to 3 over 18 plus 1 over 18, which is 4 over 18, which would reduce to 2/9. So 1 over R2346 is equal to 2/9. I cross multiply, so R2346 is equal to 9/2, which comes out to be 4.5 ohms. So this is equal to 4.5 ohms. Again, a lot of times when you do this on your calculator, you make a mistake. These numbers are simple enough, I can just look at it and do it in my head. Okay, now I look over here. I'm left with 3 resistors in series. Okay, so I want to find an equivalent resistor that I'm going to call R12345 or 1, 2, 3, 4, 5, 6. That's kind of a mouthful, so I'm going to call it RT for total, because that's the one equivalent resistance. Now, these are in series, so to find RT, what I'm going to do is I'm going to say that's R1 plus R2346 plus R5. So that's equal to 1 ohm plus 4.5 plus 0.5. So RT is equal to 6 ohms. So if I was to add all these resistors up, an equivalent resistor would be this one that would be 6 ohms connected to the battery. Now before, they told us the voltage of the battery. In this problem, they don't tell us the voltage of the battery. Normally we would find the voltage of the battery and we would use Ohm's law, find the current and work backwards. But they don't tell us that. So we're going to have to use what they give us. So what they give us is, the only other thing that they give us in this problem is they tell us that V3 is equal to 30 volts. So I'm going to go over here and say V3 is equal to 30 volts. Now remember, with Ohm's law, V is equal to IR. If I know two things, can I find a third? Yes. So here, I'm going to say V is equal to IR. I is equal to V over R. So V is 30 divided by 10, so this is 3 amps. Now, resistor 2, 3, and 4, how did I add them up? What was their relationship? Series. These are in series. What is the same in series? What is the same in series? Current. So if this is 3 amps, this is 3 amps, and this is 3 amps. Now, there's more than one way to do this. So I'm going to show you one way, and then we'll check it another way. So the voltage drop across this resistor here, V4, would be IR. So 3 times 5 is equal to 15 volts. This I already found was 30 volts. And then the voltage up here would be 3 times 3, which would be 9 volts. Now, there's 2 ways to do it. Whatever way you're going to do the next step, you do the other way to check your work. Voltages, when voltages are in series, when resistors are in series, the voltages add up. Now, these 3 resistors I added in series to get this. So if this is 3 amps, this is 3 amps, and this is 3 amps, that means that this is 3 amps. These 3 added up to R234, but the current is the same in series, remember? So if I did here V is equal to IR, I get 3 times 18, which is 54 volts. But let's say I didn't remember that, or I want to check it. Let's go back here. In series, what's the relationship between the voltages? They add up. So if I want to check my work from up here, I'm going to add V2, V3, and V4. So if I say V2 plus V3 plus V4, that should come out to be V234. So let's add it up. 9 plus 30 plus 15 is equal to 45, and 9 is 54 volts. So do you see how I get the same answer either way? I always have a way in circuits to check my work. So if you do this problem, either you would add up these voltage drops to get the voltage here, or you could just say, I know the current is the same. Either way, I'm going to get the same answer. Okay, so now what do I do next? These 2 resistors are in parallel. So now I'm going to say to myself, what is the same? What is equal in parallel? What is the same? Voltage is equal in parallel. So if the voltage here is 54, that means that the voltage here is 54. Do you see why I'm using my diagram to teach you how to do it? You have to use your intermediate schematic diagrams to solve the problem. If I have R and V, can I find I? So I is equal to V over R, so 54 divided by 6 is 9 amps. Now remember, the total current that's coming out of the battery is going through here, and then it splits. Part of it goes here, part of it goes here, and then it meets up. So that means if I have 9 amps here, and I have 3 amps here, that means that my total current has to be equal to 12 amps. My total current has to be equal to 12 amps. Now, remember, this is my total. There's another way I could get that 12 amps. This resistor and this resistor were added in how? How were these 2 resistors added? Parallel. What's the same in parallel? What's the same in parallel? The voltage. So that means this voltage would be what? 54 volts. So what's 54 divided by 4.5? I could say I is equal to V over R, so 54 divided by 4.5 12. Is that what we got here? So the current here is equal to 12. Now in series, what's the same in series? What's equal in series? Current. So if this is 12, this is 12, this is 12. So once I have R and I, can I find V? So here I can say V is equal to IR. So 12 times 0.5 is equal to 6. I can do it up here. 1 times 12 is 12. And I can add them all up. Now, there's a couple of ways I can check my work. So let's say I want to find VT, which I haven't found yet. Okay? What I could do is I could use this resistor here and say, okay, I know RT is equal to 6 ohms, and I know that IT is equal to 12 amps, so V is equal to IR, so VT times IT is RT, so I could say 12 times 6 is equal to what? What's 12 times 6?
72.
72. So the total voltage of the source is 72. But let's say I want to check my work. I want to make sure I didn't make a mistake. I can go back to this diagram. Since these are in series, what's the relationship between voltages in series? They add up. So now if I add up 12 volts, 54 volts, and 6 volts, what is 12 volts plus 54 plus 6? 72. See how it all adds up? So in circuits, you always have a way to check your work. So there's more than one way to do it. As long as I know this is easy. If I don't know in series the current is the same, in parallel the voltage is the same, no. And again, the only way to do this problem, the only way, is you have to have intermediate schematic diagrams. If you don't have your intermediate schematic diagrams, you're not going to be able to do this problem.